Hello, my dear friends. So do you remember this PowerPoint that we discussed before the exams? So we were doing chapter 9, electric power and energy. The outline was, let me pick a pen. It was actually electric appliances, and we discussed that. Electric power, and we discussed that. But we never had the chance to do electric energy and Joules effect. All right, so quickly let's go over this. So you need to remember what's the rated power and the rated voltage. You need to remember how to find the power being U times I with the appropriate units. You need to remember that for a resistor, you can simply replace U by Ri. So you will have Ri times I, which is Ri squared. And one day you had a problem where you need to replace I by U over R. So you had U times U over R, and you ended up with U squared over R. Remember this as well. Now we need to discuss, this is an example where you needed to find the current, and you did a lot of these in the problems that we did in the book. Now the first new slide is this, electric energy. And for me to be able to discuss electric energy, I took an example that I thought was funny. So Maria, Peter, and Yasmin doing push-ups and timing themselves. All right, I wish we are in class, probably we can try this. And the question is, who spent more energy? This is the first question. And the second question is, who is more powerful? I'm so sorry, Peter, I took you as an example, and as you can see, everybody was beating you. We know this is not true. This is only to give the girls some motivation. Or probably it is true. I don't know Maria and Yasmin enough. Who knows? So, who spent more energy? The student who did more push-ups is the students who spent more calories and therefore more energy. And as you can see, Yasmin did the most out of it. So who spent more energy? I'm gonna say Yasmin. Okay, and let me make this a bit bigger. So yeah, it fits. Who is more powerful? Let me see. Maria did only 20 push-ups in 20 seconds. Peter did 20 push-ups in 40 seconds. So who is more powerful? Who was faster? Who was stronger? Definitely Maria, because she did the same exact thing in less time, right? Now, if you want to compare Peter and Yasmin, probably Yasmin is more powerful because she did more during the same time. If we need to compare Maria and Yasmin, it's a little bit difficult, but I can say probably Maria is more powerful because 20 push-ups in 20 seconds, and this is only 25 push-ups in 40 seconds. If they were having the same power, probably Yasmin should do 40 in the double amount of time. What does this mean? It means that the more push-ups you do, push-ups is the energy, the more power you have, and the less time you take, the more power you have, which means power and energy are proportional. Power and time are inversely proportional, and this leads me to the equation power to be energy over time. I took the energy to be in the numerator and the time to be in the denominator to show that power and energy are proportional, power and time are inversely proportional. Now let me write this equation differently. I'm going to write that energy is equal to power times time. Okay, so, and probably write the triangle for it. Energy is equal to power times time. I hope while listening to this video, you're actually taking notes, okay? Because it looks so much better with your handwriting. Let me pick the green pen to use for the units. Or probably let's take more space to use for the units. No, let me use the space. This is gonna be in joules and not in calories. Calories is a good unit for energy, although it's not the SI unit. Time will be used in seconds, S. And power, remember what was the unit for power? Do you remember the unit for power? It was watts. Okay? Yes. Now we have another slide in which I need to discuss the energy for a resistor. So we already wrote that energy is power times time. In this case, how can I find the power P? You have many methods to find the power P. And let me remind you, P can be U times I. For a resistor, you can write RI squared. And as you learned from the problems that you have solved, you can also replace this by U squared over R. Okay? So for a resistor, you can use this one and this one. For any other appliance, and this one as well for a resistor. For any other appliance, you can only use this one. Okay, now I kept this empty space for the units because I believe we need to discuss units more thoroughly. Okay, so E is P times T, right? Let's say this is in seconds and this is in watts. The energy is gonna be in joules, and this is what we already did in the previous slide. Now, how about I keep this in watts and this in hours? The energy is gonna be watt hours. And this is very possible. It's not the SI unit, I know, but it is accepted. If this is in kilowatts and this is an hour, can you guess what would be the energy? It's gonna be in kilowatt hour. And this unit is actually used thoroughly, especially when your parents are paying the electricity bill, they actually pay for the kilowatt hour. Okay, now quick reminder, if you need to convert from hours to seconds and the opposite as well, you do multiplied by 3,600. And if you want to convert from kilowatt, and the opposite you do divide, and from kilowatt to watt, can you guess? Kilo is 1000, so you multiply by 1000. Cool? Yes? All right. Now the last slide is about Joules effect. What is Joules effect? Joules effect is, you know, the energy that is P times T, and P is RI squared. Every time you have a resistor, the resistor's job is not to dance, not to create music, not to create noise, not to create motion. The only thing that the resistor does is to slow down the current and to heat up. So, and this heat is called the Joules effect. So it is about heat or the energy given by the resistor. Now the question is, the Joules effect, is it an advantage or a disadvantage? I give you many examples randomly. The iron, it does heat up when you want to iron your shirt. The radiator, I mean the thing that creates heat. The laptop would heat up. The water heater would heat up. The iPad charger does heat up. The fan would heat up. You know, the fan, if you put your hand behind on the motor, it is hot. The TV would heat up. The bulb is very hot. It heats up. The hair dryer also heats up. Now the question is, and you can think of other appliances you have around you, anything around you would heat up. Are you making use of this heat? For the iron, for example, yes, I'm using the heat to iron my shirt. For the radiator, I'm using the heat to warm up my room. For the laptop, I'm not using the heat at all. I'm bothered by the heat. For the water heater, I'm using the heat. iPad charger, I'm not using the heat. I'm not heating my coffee on the iPad charger, come on. So, which means the heat is actually lost. The heat, I'm paying for it, but I'm not using it. For the fan, I'm not using the heat at all. And I'm not happy that the fan is heating up. The TV as well. For the bulb heats up. Am I using the heat? Am I warming my hand on a bulb? Am I heating my coffee on a bulb? Am I cooking the eggs on the bulb? No. So the heat is not bothering me a lot, but it's energy lost. I'm not using it. Hair dryer would do many things, including drying my hair and making my head a bit warm. So I'm using the heat, it's not a disadvantage. So Joules effect is an advantage whenever you are using the heat, like in the case of 1, 2, 3, and 4. It is a disadvantage whenever I'm not using it, like in the case 1, 2, 3, 4, and 5. All right, keep that in mind. I'm gonna save the slides, these slides, this presentation, and I'm gonna give it to you. And you can watch the video again every time you need to be reminded of anything. All right, thank you so much.